Please note that this is the abbreviated version of this video. If you have any questions and you're having any trouble, first watch the full version and then ask your questions there. I'm going to disable comments under this one, but I'll be answering questions under the other one as long as it's not something that I answered in the video. So go ahead and ask your questions there. And of course, the link is in the description. And as I mentioned before, since this is a hacky kind of mod, there's a million different ways you could do it. I came up with a method that I think is the easiest for somebody who's just approaching it and wants a straightforward way to do things, but feel free to check out other methods on the internet and see what works for you. It's all going to depend on what your skill level is, what you're comfortable with, and what is going to work best for your setup. Step number one, basically we're converting our ramps to a 3.3 logic board instead of a 5-volt logic board. You can keep it 5-volt logic and instead change your peripherals, but that adds additional difficulties, and this is the easiest way to do it. So after we're done with that, we're going to jumper 3.3 volts to the ramp's 5-volt bus. Then we need to cut any of the ramp's unused pins that are different on the Duo than they are on Omega so that we can reuse those pins for things that we need, which are specifically jumpers for our thermistors. And then we can also add additional jumpers off of our 5-volt rail from our Duo to 5-volt peripherals if that's something you require. And we definitely have to replace the Mosfets if you want it to actually function as a printer. And then a few other things that you may want to consider. I'm just going to throw these out there so that you don't think about it later and say, duh, I should have done that while I had the board taken apart. Now, here's what they look like side by side. What we're going to do in our first step here is we need to take all of the pins that are feeding 5 volts from the Duo to the ramps, and we're going to remove those pins in some way. We are just going to be snipping them off because I think that's the simplest and the easiest to undo. If you want, you could just solder a new pin in there. Specifically, what we're talking about is right here. If you look on the diagram on the left, the upper left-hand X with the little orange arrow on it, that's our 5-volt pin. It's going bye-bye, and then we are going to bridge our 3.3-volt pin from our Mega to that 5-volt pin, so then we have 3.3 volts on the 5-volt rail. And then those pins on the bottom right that are feeding 5 volts from the double rail header, we are going to clip those off so that they're not feeding into the ramps board, and we're going to put a little DuPont jumper so that we can send that to whatever peripherals we need to run at 5 volts. Next step is these 4 pins that were analog pins on our Mega, they are not on the Duo, so we're going to snip those off. And on the header next to that, we're going to run our little jumpers for our thermistors because those are not in the same place since the pin designations are wrong. Then where you see the big circle and X in purple, those are our Mosfets, which are not going to work, so we will have to replace those. And just ignore the pink arrow. If you want to know what that's about, go watch the full video. What you need to do on the top is you take this second pin here and a third pin here, and you're going to bridge them with a little piece of solder. Just blob it right across there. That's going to bridge our 3.3 volt feed from the Arduino to the 5 volts. Then we have the bottom side. So here's our 5-volt pin. It's 3 pins in. We need to cut that. Then we have these 4 pins over here that are completely different designations on the Duo and the Mega, so those have to go too so that we can hook up our thermistor jumpers on the other side. Then all the way down on the bottom, we have our aux 4 header where we're going to get rid of this 5-volt connection right here. So that way we're not tying our 3 and our 5 volts together and doing any weird short circuit stuff. And then if we're using multiple thermistors, we only have a hard connection on a trace for the one thermistor. So if you want to use the other 2, you're going to take those pins that we clipped from the ADC or the CAN bus, and we're going to jumper those over the board onto the aux pins that correspond to those. I'm going to take this pin right here, the second from the last, and we're going to jumper that over right here to this pin on the header. Then we're going to take the pin next to it and jump it right over here to this pin on the header. And those are going to be inputs for our thermistors. And then if you're going to be hooking up a 5-volt display or a panel or something like that, you're going to have to get power to it somehow. So I just soldered one of these DuPont jumpers to the 5-volt header on aux 4 and run that around the board and to the connectors for that. Next part, and this is important, are the Mosfets. The Mosfets that were originally spec'd on the ramps were actually meant for a 10-volt logic voltage. The original Mega puts out 5 volts, so it wasn't even sufficient, but they found that they did kind of turn on, but as we know, not well enough, because we have a lot of problems with these MOSFETs heating up and catching fire and that sort of thing. So they are certainly not going to work at 3.3 volts if they didn't work at 5. So those are going to have to be upgraded. Now, sometimes these RAMPS boards have upgraded MOSFETs, but usually they're not going to be good enough to run a hotbed at 3.3 volts. But they may be good enough to turn on at 3.3 volts. So if they are, then you can easily use an external MOSFET board to feed your hotbed, or use it to feed your hot end. It doesn't care. Now, I know from testing that the IRL-S and IRL-B 3034 MOSFETs do work. Also, down at the bottom, the IRL-B 8743 MOSFETs, those are reported working. I have not tested them myself, but they use them on like the RADs and the RAMPS FD and that type of thing. And then users have reported that the IRF 3205s that often come as an upgrade on certain RAMPS boards, those do at least turn on. I'm not sure how much current they can handle and how much temperature they would put out, particularly for the heated bed. But if you do find a board with those on it and you're paranoid about the heat bed, you can run an external MOSFET or just replace them. Now, as far as end stops, the RepRap mechanical end stops will work just fine at 3.3 volts. They really don't care. Optical end stops and other types of fancy end stops, that's a different story altogether, and it varies drastically depending on what board you're using. As in, some will be able to run at 3.3 volts and some will not. Just make sure that you're not running 5 volts to your optical end stops to get them to run, because those are going to output a 5 volt signal and fry your Duo. As I mentioned in the previous video, the only stepper drivers that will work are either stepper drivers that derive their own logic voltage through an internal regulator from your VCC rail, or stepper drivers that can take a 3.3 volt logic level. That means your original silent step stick TMC 2100 5 volts will not work. But pretty much all of the other stepper drivers that I've encountered worked. I would have to take them on a case-to-case basis, so make sure you check your data sheets. Allegro A4988s, they will work. Also, your Texas Instruments DRV8825s, they work just fine. They don't care what the logic voltage is. And there are actually like a dozen or so more types of drivers that use the step stick format. I didn't check every one individually, so just, like I said, check your data sheet, make sure they're cool. Finally, if you want to use an integrated panel, the RepRap Full Graphics Smart Controller is already set up in Marlin to work with this board. There are no hardware SPI pins on the aux header that the smart adapter uses, so you're using software SPI for both the display and for the SD card. Software SPI runs a lot slower than hardware SPI, but it does work. If you want to use hardware SPI, you're going to have to run it from your SPI port, which is where your ICSP programming port was on the Mega, and then just run them out of the side of the board like this. You can use a hardware EEPROM. This is an I2C adapter board, and those will just plug right into your I2C header on your RAMPS board, and then you just have to configure them in Marlin. Remember, this is a hack. We are not prepared for legacy peripherals, so be careful and never run a 5 volt signal into a 3.3 volt input, because you will blow it. Going from a raw 5 volts to a 3.3 volt input is always going to be a bad day. Depending on which peripherals you're using, that can also mean your leveling probes, at least the older ones that aren't 3.3 volt compatible, thermocouples, piezo sensors, comm peripherals that might be 5 volt, etc., etc. So better safe than sorry. The Duo cannot put out as much current as the Mega did, so if you get a situation where you're randomly rebooting or shutting down, you're drawing too much current. Many of the Duo clones used incorrect values for some of the resistors, and they're prone to conductivity problems and other reboot problems. Now, like I said before, I do consider this to be kind of an advanced hack slash mod, just because the actual mod itself, the doing of it isn't that tough, but knowing what you can plug into it and what you can't run out of it, that's where kind of a little bit of a know-how in this area works. And that's just because peripherals have to be taken on a case-by-case basis, and the only way that you can be sure whether or not they're going to work would be to pull up the schematic, pull up the data sheets, and to see if it is something that's going to be able to work with the voltages that are going out and coming in without, you know, actually hurting anything. And then there's always the issue of being able to handle desoldering and resoldering the Mosfets and having that set up safe as well. Plus, all of the RAMPS problems that you had before, they still apply, and they're even worse. So you have to think about the thermistors, you have to think about the Mosfets, and you have to think about the ratings, the current ratings of the connectors coming in and going out of the board. Like I said, I picked the method that I thought would be the most friendly, user-friendly, and that would work best with the profile that's built into Marlin 2. Now that brings us to a completely different issue, which is installing Marlin 2, which is their 32-bit branch. This does work, and I do have it running on my printer. I had several successful prints after everything was set up and calibrated. So all of the fringe cases and the problems don't have to do with the mod themselves, but rather what you're plugging in and out of the board. And as I mentioned before, I kind of dread becoming an unofficial resource / product support for this mod because it is a hack and it is iffy. It is a little bit dangerous if you don't do things right or if you're lazy about it. And you have the potential of wrecking your gear. So safety first, but with the virtually infinite number of different variations, I don't have time to hit on everything that's out there in the market. And I have an ever increasingly large pile of videos that I need to get edited, as well as working on the projects themselves for new things. This all takes a huge amount of time. If you want me to be able to keep doing this, remember I always have support links in the video description below. And as I always say, until the next video, get out there and make something awesome. Or get out there and mod something awesome. And then take your mod and make something awesome.